This video is going to be pretty much the same thing as the other one where we're solving for x using similarity in triangles where we set up our proportions and then solve for a variable or solve for a side depending on what the problem states. The only difference between this video and the other one is that supposedly this is tends to be harder just because of how the shapes look. Okay, so let's start off with reading the directions. So if triangles ADE and ABC shown in the figure are similar, okay, so there you go. That we know that we're going to be able to create proportions here. And then what is the value of x? So let's look at the names, because if you recall, that is what's actually super important, okay, because the name actually matters how it goes. So the proportions, the first two letters are A and D. So AD is going to be proportional to AB. Okay, so that's going to be one of them. And then we just keep going. The next two letters are DE. Sorry, it doesn't even look like a D, but you get the point, okay? It's going to be DE is proportional to the second two letters. So it'll be BC. And then finally, the last one is going to be the first letter and the last letter, which is AE. Is going to be proportional to AC based off of the names, okay? And so now what we can go ahead and do is try to substitute. We're going to have to do just a little bit more here for one of these sets, either the numerator or denominator. You'll notice right now. So AD, so let's start off with the first one. AD is this right here, and we see that's equal to 2. So that's not too bad. It's 2 over. And now this is the kind of tricky part, and I'll do it a different color. AB. So AB is actually going to be the entire side length. Now, if you notice, it's broken up into two sections. The first section is 2, and then the second section is 4. So we're actually going to add those two numbers, and that means that AB is equal to 6. Now, if that sort of confuses you, what I completely suggest you do is just redraw the triangles separated. So for instance, this one here is going to be my ADE, and then the bigger one is going to end up being my ABC. Okay, and then you can see there why it actually makes sense. So 3, 2x, just because it's off of the picture. 12 goes there. We have this little section being broken up into like 3 here, but we don't have this at all. So what that means is I have no idea what AC is. It has to be more than 3, obviously, but who knows how much more. And so then the last side, which is AB, is going to be equal to a section of 2 and a section of 4, and together that obviously makes a section of 6. Okay, so that there is if you need it. Some of you may need it, some of you may not. It's completely up to you. And so now let's go. DE is going to be equal to this one right here, which is equal to x. BC, which is equal to 12. And then the last one, AE, which is equal to 3, and then AC, which we actually don't know, but we definitely know it's more than 3. So what I'm going to do is you can go ahead and choose different things to say. You can say AC, or you could even get a little bit more creative, and some of you might not like this, but it's actually, like valid. You can go ahead and do 3 plus, you can even say like EC, if that's something that could work with you, but it doesn't really matter for right now. And so now let's, the directions basically says we just need to solve for x. If you notice, this one here has no x in there whatsoever. So it's basically like useless for us in this problem. And so what that means is that these two are going to basically give me my answer, right? We're going to cross multiply, solve. This is a pretty nice, easy problem to solve. So cross multiplying. So right there, it'll give me 24 equals 6x. We divide by 6 on both sides. So it's actually pretty straightforward, pretty easy problem. X equals 4. One thing that the questions that I get all the time is, what if you like flip-flop it? Instead of doing 2 times 12 first, you do 6x first. So let me go ahead and let's do that. So imagine that I said, hey, what if 6x is first? Does that actually matter? It doesn't really, because all that's going to happen is the x is going to be on the left side now, right? Instead of being on the right. But you're going to get the same answer anyways, okay? So there you go. That's the first example. Like I said, this video is meant to be have more complicated problems, but it's definitely not meant to throw new stuff at you. You're just going to do the same thing, but just at a different level. But for this one, I'm just going to go ahead and jump into my proportions, right? It'll be AB is proportional to FE. And then that one is, and then that's the first two letters. The next two letters will be BD is proportional to EC, and remember, it all just comes from the name. And then AD is proportional to FC. I basically don't even look at the diagrams if if I'm given the similarity notation. And so after that, I'm gonna go ahead and substitute for every single one of them. Let's see, AB. Now this is where I look at the diagram. AB is equal to 3 over FE, which is equal to 8. BD is equal to, right here it's given to us, so it's x minus 1 over CE or EC. It doesn't really matter the order, right? EC is the exact same thing as CE, okay? Because you're basically talking about the same length. And then AD is nothing. There's no information given to us. FC, nothing at all. So this becomes kind of useless. So then we end up with this one here. I'm going to write it on the top just because I have a little bit more space. X plus 2. And so what we can go ahead and do now is cross multiply. Some of you are probably already noticing that this one does look different. Because if you notice, there's two x values, or two expressions, and let's just see how it actually affects it. So cross multiplying, since there's expressions on both of them, I'm going to go ahead and do parentheses for both sides. So 3 times x plus 2 equals 8 times x minus 1. So I'm going to distribute on both sides because that's what I have to do. And now it just becomes a problem of isolating the variable on one side. You completely decide. It doesn't really matter as long as you're doing the correct math. But I will go ahead and I'll subtract 3x on both sides just because I don't want to work with a negative x value at the end, just in case I forget to divide by a negative. So 5x minus 8, then I'll add 8 because I am trying to isolate the variable. So 5x equals 14. And then after you divide by 5, you're going to end up with a decimal, and that is totally fine as long as everything you've been doing is completely accurate. And so we end up with, let's go ahead and let's get x is equal to 2.8. And if you notice, that's what the directions say. So this is my final answer. And I feel good about it because even though it's a decimal, it doesn't matter. I've been doing everything, correctly. Okay, I set up my proportions. I substituted correctly and everything. Okay, so let's go ahead to the next one. Ignore the drawing or the figure right now. Okay, you're gonna just focus on the name. All right, so go ahead, try to do it. Pause the video, see if you can do it by yourself. My proportions are going to be equal to, let's see, this is GI over HI, IF over IJ, and then GF over HJ. Okay, substituting. GI is going to give me, if you notice, GI is this long one. So if you need to, go ahead and separate the two triangles. Notice how they're the longer side is going to be the addition of the two sections if they give it to you. If they don't, we can just leave it as a question mark. So let's see, GI is going to be equal to no idea. HI is going to be equal to 11. IF is going to be equal to 15. IJ is equal to 10. GF is equal to 12. And then that one's equal to X. Since this proportion has a question mark in there, that means it's not helpful at all. So then therefore these two are the ones that are going to give me the answer. I can go ahead and cross multiply and then solve, right? Cross multiply, it'll give me 15x. Let me go ahead and change color on that. It'll give me 15x is equal to, what is that? 15x, 10 times 12 is equal to 120. And then we're going to go ahead and divide by 15 on both sides. And then x is equal to 120 divided by 15, which is equal to 8. Yeah, I used a calculator for that. I had no idea what it was. So anyways, there you go. Solve for x. Here goes my answer. All right. So there you go. These are the examples that, are just supposedly a little bit more complicated, but just because of the shape. My real big shortcut is, just ignore the shape, look at the notation. This would be a good challenge question for a lot of you. So pause the video, see if you can solve it. I will go ahead and solve it right now as well. Okay, so AD is over AE, sorry, proportional. Then we get DC is proportional to EB, which is then also proportional to AC over AB. And then this is where this is why I notice right now that it's a little bit complicated. So AD is going to be equal to, if you notice, it's actually this entire length. Part of it is 7, and then the other part is x. So I'm going to actually skip that one just for right now, because once we figure out another one, we're going to come back to it and you're going to see you actually do know it. So AE is going to be equal to 7. Okay. DC is going to equal to y. And then EB is going to equal to 6. Perfect. And then let's see, AC. Here you go. This is why I wanted to skip the AD first. Okay. So let's go look at AD. Oh, sorry, AC. AC. So AC is this one here. And if you notice, really think about your logic, okay? If that one's equal to 4 and then this one's equal to 2, then together that means they would give you, right, 6. But let's slow it down, right? We know it's 6, but think about how you got it. You did 4 plus 2, and then that's how you get 6. Now that there is going to be a really big hint for the AD, okay? So 6 over AB is equal to 4. Now let's come back to AD, okay? AD is going to be this entire section. Now, some of you are going to be saying, is this 7x or is this 7 plus x? Okay. My hint to you is, how did you get this 6? Right? You're adding. Okay. Because if we were to multiply, 4 times 2 is 8, and that's not the answer. So technically, this one should be 7 plus x. Okay. And so now we actually get a really interesting problem, because if you notice, we have information for everything. We have variables. We don't have any question marks here. We have everything. And so you have to look at the directions, and it says you're actually going to solve for both variables. Okay. So let's go ahead and let's think about what are all the different ways that we can write equations here with just 2 fractions, because we can't really just, completely ignore one of these fractions. So this is what I'm going to do. I'm just going to choose 2 of them at a time and create equations, and then you will see why I have to choose some of them over others. So the first one is 7 plus x over 7 equals y over 6. So that's one thing I can do. I can also do y over 6 equals 6 over 4. Or I can also do, think about it, I use this one and this one, and then I use this one and this one, which is the only one that I haven't used, well, the first one and the third one. So then I can also do 7 plus x over 7 equals 6 over 4. Now, the directions say solve for x and y. So I'm actually going to need equations where I can solve for both x by itself and then for y by itself. One of these you cannot solve at all, and it's just because your number of variables is higher than the amount of equations you have in that moment. And technically for that one, it's going to end up being this equation right here. If you notice, I have 2 variables, y and x, but I only have one equation there that I can work with. So what that means is that this equation is impossible to solve. Okay. Yeah, I don't know how to spell impossible. Impossible to solve. Okay, you just can't solve it based off how it looks right there. So we go back to the other 2 equations that we have here. Only one variable, all numbers. Only one variable, all numbers. So what that means is that you can actually solve these two equations separately, and then that's how you would get your answer. So that's what I'm going to go ahead and do. Okay, so cross multiply, and so we get 4y equals 36, and then we divide by 4 on both sides. So then y is equal to 9. Okay, and look, there you go. I got my answer for y. So you actually have 2 choices now. One of them is super extra than the other one. You can plug in the y in here, and now this problem actually you can solve it because you only have one variable, which is x. Or you can just go back to this here and cross multiply and do the work. So that's what I'm going to go ahead and do. Okay, so it'd be 7 times 6, which is what is that, 42, is equal to 4 parentheses 7 plus x. Remember, I'm gonna write the parentheses every single time. 42 equals 28 plus 4x. Subtracting 28 on both sides. What does that give me? Subtracting 28. 4x is equal to, yeah, I have no idea. So 42 minus 28, which is going to give me 14. And then 14 divided by 4 is going to be equal to 3.5. Okay, so that'll be my last answer. X is equal to 3.5. Okay. Now, if you remember the problem stated, solve for x and y, and there goes my two answers. So this problem actually came out to be way harder than I remembered, but that's totally fine, right? We didn't do anything different, okay? The only thing that was different was honestly this part right here, this 7 plus x part. But if you really think about it, you already know how to do that because that's how you get your 6, okay? So that right there is going to be the last example.